This illustration added to the rest of the lesson is going to help you remember that when you are adding or when you are multiplying, everything needs to be multiplied. Both pieces, the 40 and the 6 get multiplied by the 2. The 40 and the 6 get multiplied by the 10. To look at it with polynomials, the first one I want to do with you is going to be, it's going to emulate example 1. And example 1 for me is going to be, I'm going to give you a different one. I don't like the one they gave me. That one's stupid. It's going to be this. X plus 3 multiplied by x squared plus 2x plus 4. Here we have a number that you could think of as a 3-digit normal number. Take like 365, I don't know. A squared, a first power, and a number. Just like 365 has 100, a 10, and a 1. And then you've got a 2-digit thing, a 2-digit number. You're going to treat that, say, like 22, a 10, and a 1. Now, there's a couple different ways you can do this, and it's really up to you. I'm going to show you both ways, and you're just going to have to figure out which way works best for you. There's the stack method, which is this, and then there's the vertical method, which would kind of look like this, and I'm going to show them both to you right now. First one I'm going to do is the stack method. Always put the widest polynomial on the top. So that means if there's ones with 3 digits, you're going to put it on top of the one with 2 digits. Justify the smaller one to the left. I know that seems weird, but justify it to the left. And instead of starting to the right and moving leftward, you're going to start left and gradually move rightward. So starting left is going to mean performing everything multiplied by the first piece of the second polynomial. So everything in the top by x. X squared times x to the first is what, guys? Yep. X times 2x. Yep, and it's positive, so don't forget to keep that in there. And positive x and positive 4. Did you come up with positive 4x? Good. So at this stage of the game, we are no longer multiplying anything by the x. Put a placeholder here. Move on to the next thing. Yep. Which is everything in the first trinomial by the 3. Should be a positive 3x squared, a positive 6x, and a positive 12. Okay? Now this is where a little light bulb, I want to make sure you're aware. You're now going to add everything up, but only according to its kind. If you stacked them right, they're already lined up that way. These are x cubes, well this is nothing. These are x squareds, this is x to the first, and that's a constant. So everything is stacked beneath stuff it matches anyway. So when you add up the result of both multiplication pieces, just like you do up here, you end up with the product. And after you've added them up, you'll notice, holy cow, I don't know why it does that. Sometimes it does, sometimes it doesn't. Like, it's not supposed to come up in front of this. Anyways, you look at these and recognize, is there anything that can be combined? No. Cubes can't be combined with squares, can't be combined to the first power or numbers. So this is your answer. Nothing more can be done. Now the other way to do this, you know how we added the two results together? You can do the same thing horizontally. You can first take the x and multiply it by x squared plus 2x plus 4 and add it to the result of 3 times the x squared plus 2x plus 4. It's going to give you a big long run-on polynomial, but you can do that as well. So boom, we've got that, and we'll end up with x cubed and 2x squared and 4x. Does that look like the first line to you? Sure does. All of this is going to get added to the result of this. 3x squared added to 6x added to 12. Does that look like the second line? Same thing, isn't it? That should be a 3 right there. Combine all your like terms. Well, we already know x cubed is by itself. There's nothing else to combine it with. X squareds, there's 5 of those. X's, there's positive 10 of those. All that's left is my number. And you could probably see that these two match. But it's a matter of whether or not you like this being the horizontal method or you like the vertical or stack method. I don't care. The book says use vertical form, use horizontal form. I will never tell you how to do it. I want you to choose whichever method seems to speak to you. If you want to practice them both, feel free. But on your ACT test, they're not going to say to you, use the horizontal method. They're not going to care. Okay? And remember, when you do take those tests, they don't give you an infinite amount of time. So learn how to do it the way that's comfortable for you.
Didn't you add 5x and 10x?
This is to the first. Sorry. That should be to the first. Yep, the 6 and the 4 is to the first. Sorry. Use whatever is comforting to you. Thank you, Morgan. Okay, that's one version of example 1. If you look at your homework, there's a couple of different things you're going to see. You're going to see 3 by 2 mostly. This is 3 by 2. You're also going to see 2 by 2, which is just another version. We're going to practice that in a minute. It doesn't matter if it's 4 by 2, 4 by 3. The same technique stands, just like you did when you did big multiplication. Like take, for example, 1,236 times 454. Okay, you could do that, and we're not gonna. But you multiplied 1236 by 4. Then you added that to the product of 1236 times 50, which you added to the product of 1236 times 400. All of those layers eventually added together to give you your answer. And that is what example 2 looks like. Okay? But what I do want to show you in example 2 is how when you're given problems, sometimes there's some thinking you can do to actually make the multiplication a little bit easier. I'm not going to do theirs, so I'm going to give you a different one. Example 2 shows us that if you arrange your factors in decreasing degree of one of the variables, if there's 2 variables, it makes the stacking, adding method a whole lot easier. Take, for example, 1 plus 6x and have it be multiplied by 4 plus 2x squared plus 3x. Now, degree has to do with the power of the exponents. The exponents with the highest power get listed first in decreasing degree. So here, the 6x has a power of 1. This has no power at all because it's not a variable. So rewriting this 6x plus 1, and then rewriting this, which of these has the highest power? Yep. Followed by 3x, and the 4 wraps it up. Okay? Again, depending upon what you like to do it your way. Is there a particular method you would like me to show you? Do either of you, do you care? None of you care? All right, I'm going to do stacking because that's just how I usually do these. I don't usually write the multiplication symbol. So we're going to start to the left, opposite of the normal numeric multiplication, and you end up with 12x cubed positive 18x squared positive 24x. We are now done with the 6x, which means nothing else is going to go here. Here we go. Positive 2x squared, positive 3x, positive 4. For whatever reason, I seem to make less mistakes when I do the stacking method. 12x cubed added to 20x squared added to 27x added to 4 is your answer. If you wanted to break it apart, you would do the trinomial times 6x, that product, which is this, added to the trinomial times 1. That product then gets added to the first, giving you your final answer. Nothing can be combined, so you are done. Okay? But if you do not list them in decreasing degree, your stuff will not line up. And you'll be wondering, why do I have x cubes lining up with x squareds? This would be the reason why. See, in normal numbers, we're always lined up, aren't we? Which is why your ones always add together, your tens, your hundreds. Whatever is in these layers adds together without any thinking because you have everything layered in decreasing degree or decreasing place value. You have to think of this technique as the same thing. Okay, one final thing I want to show you. And it's not illustrated in this lesson, it's illustrated at a later date. Did Morgan, Leah, Jaden, did you guys ever hear the word FOIL in math? Did I ever teach you guys that word, FOIL? Tiana, do you remember? Okay. They don't teach this soon enough, so I just want to add it in for you. Those two techniques aside, what I just showed you are how you're going to want to do 3 by 2 or 4 by 3. But if you have a 2 by 2 multiplication, that is a binomial multiplied by a binomial, then this method is the cleanest method that I like to use. And the device, the word FOIL, gives you direction on how to perform the multiplication. And I'm going to tell you what these stand for. First, outside or outer, inside or inner, and last. That is the order within which you perform the multiplication when you're doing 2 by 2. Take, for example, q plus 2 multiplied by q minus 7. Okay? Instead of stacking or breaking it apart, I follow the FOIL method. The first two terms get multiplied together first. That gives me q squared. Then the outer two terms get multiplied. That's a negative 7q, right? That's the outer two terms. Then the inner, which is a positive 2q. Remember, this is separate, so I know you might have a question at this point. Finally, that's the inner. Finally, the last two terms. After you have successfully FOILed all 4 steps, look for any combination activities that can be done. Most of the time you'll be able to combine. Sometimes you won't. Most of the time you will. And in this case, you end up with q squared minus 5q minus 14. Squares can't be combined with q's, which can't be combined with numbers. Okay, you are going to hear more about foiling, but I feel like I would be wasting your time not to mention it now, because I feel it's the best way to do 2 by 2. Okay. All right. Go for it.